So I'll have you come on up here and give these a try. I'm going to give you the square root of 24. I'm going to give you the square root of 8. I'm going to give you the square root.
Oh, these are ones that like are whatnot.
Yep.
Okay.
And then up here in red, I'm going to put some of the perfect square root numbers that you're looking for. Because those are the big ones you're looking for. All right, pass the pen to you, Kim.
Okay.
So if you have 24, I need two numbers that give you 24, where one of them is one of these perfect root numbers.
4 is 12.
So these are all the perfect root numbers, or the numbers that give you 24. 24 is 1 times 24. 24 is 2 times 12. 24 is 3 times 8. And 4 times 6. So out of all those pairs, do you see one that has a perfect root in it?
4 times 6.
Yep. So you remember how we
Wait,
write
I'm
it?
gonna look for it.
If we did one right here is where we started doing those. Where you find those numbers.
Oh, okay. Okay.
Yep. And then you remember what number to write first?
Yeah, 4.
Yeah, yep. Yep.
Okay, and then I do.
And you break it into two little separate square roots. Yes.
6. And then 2.
Beautiful. Can't be simplified anymore. 6 has no perfect root in it. It would give you a decimal at that point. Perfect root. All right, 8.
4 times 4.
4 times 4 would give you 16.
Oh, wait. 4. It's
So here are all the numbers that make up 8. You got 8 times 1, or 1 times 8. You have 2 times 4. I think.
Oh yeah, 2 times. Yeah, sorry. I'm blinking at it. Okay. Oh, 4.
Yeah.
2. Okay. 2. Oops.
Good. Yep. And that's perfect. That's a whole number 2, but don't touch that one. Leave that one right. That's perfect. Good job, girl. That's your answer. All right. How about 18? Let's erase some of it. Any numbers?
9 times 2.
Good. Perfect. Yep. Good. And then you split it. Good job. 3 root 2. Good job. 50.
Oh, wait, 5 times 10.
5 times 10 gives you 50.
Oh, but it's
the
not.
problem with 5 and 10, neither of those is rootable. Any of these in 20 or in 50?
5, 10, 15, 20, 25, 30, 35, 40, 45, 16, 25? 5 times, or 25 times.
25 times what gives you a 50? How many 25s give you 50?
2.
2 of them, right? So 50 is broken up into 25 times 2. Yep, because that gives you 50. Yep. And then you split it.
5.
Yep, perfect. 5 root 2, perfect. I'm going to circle those in green for you. You did excellent. And then if you are watching at some point, remember that the reason why you write the 4 first, this is a common mistake I see if you're watching this. If you write the 6 first, I've seen people do weird things when they write the one that can't be rooted first. Like I've seen them write it 6 and 2, and I've seen people write it like 6 root 2 by mistake and stuff like that. So yeah, always write the perfect one first. All right, these ones a little harder. If I give you square root of 32, this is a perfect example of one, because for this one, you're looking for the biggest perfect root in it as far as you could go. So try this one. This is a challenge. 32.
So 25.
And then over here, I'll help you out. These are, because I've been doing math so long, these are all the numbers that times to give you 32.
Okay. Oh.
Yeah, yep. Yeah. Perfect. All right, now, did you simplify it as far as possible? Can you break down 8 anymore?
Yeah.
Yeah. So for a problem like
4.
this, if you were to take out a 4, what happens is you're left with a number at the end that still would have to be broken down. So if you had to do this one further, you'd have to say, okay, 8, I'm going to leave this 2 alone. 8 is 4 times 2 again, which is 2 times root 4 times root 2, which becomes 2 times 2 root 2, which I'm just trying to get to you, gives you 4 root 2. Do you see that?
Mm-hmm.
But if you were instead, Camille, instead of using 4 and 8, which is perfect, if you were to use this pair right here, it's called going for the biggest root. Watch what happens when you use this one. If you use 16 and 2, the beauty of looking for the very biggest root possible is when you split this, it ends up being the final reduced answer, but just in one step, where if you did it like this, lady, you would have to break down 8 again to get the real final answer. So that's why when we're looking at this, when you're looking at like pairs of this, go for the biggest root, because you did the 4, which is beautiful, which would just make you have to keep going. Where if you would have took out the 16, you would have done that simplifying in one step. It's kind of weird.
Okay.
I'll try another. Try this guy. I'm going to give you a square root of 9. We'll start off with this one. Square root of 9 over 16. How do you break down a fraction radical? Good job.
Wait, 2. Wait. 7.
No. 7. 7 times 7 is 40. What times itself gives you 16?
Oh, wait. 8? Yeah, 8.
Well, 8 times 8 would give you 64.
2? Wait. Oh, what times itself give?
You start off with the ones. What's 1 times 1?
16.
1 times 1.
Oh, it was 1, sorry.
What's 2 times 2?
4.
3 times 3?
9.
4 times 4?
12. 14.
No, 4 times 4 is 16.
Oh.
Yep. So that's a perfect one. That's one.
Oh, okay.
Good job.
Okay.
Yep, and like I said, whenever you're in doubt of the perfect root, start with 1. 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. If I gave you a 1 like this one, I'm going to have you simplify the fraction, but the top number, let's see, try this guy. So do your split, good, 8 on the top, good, and that gives you
4.
No, can you square root 8? Let's see, I'm going to undo that. Nope, you don't want to put 4 there. So I would just leave it the square root of 8 for now. And then you could square root this one though, right?
Yeah.
So leave it the square root of 8 over 4.
Oh, just put 8?
The square root of 8. Put this whole thing.
Oh.
All right, now it's tough. Do you remember how we broke down that 8? What 2 numbers are part of 8 that are a perfect square root?
2 times 1.
Yep. Right. So you got to take that problem, and you're breaking down the 8. So you're doing it like this. You have that 8 right there over 4. You have to break down that 8. So that 8 would be 4 times 2, right?
Mm-hmm.
That 4 on the bottom though, you're not touching. And then this would turn into the square root of 4 times the square root of 2 over 4. And it looks like you could divide these out, but it doesn't, because this turns into 2 right here. So that would end up being 2 times the square root of 2 over 4. But that one's a little too yucky, right?
Yeah.
Yeah, let's not do that. How about if I gave you the square root of, let's see, 28. Try this guy. And I'll list, again, the perfect roots you need to memorize. You need to memorize 4, 9, 16, 25. What 2 numbers are in 28?
Oh, 4 times 8?
4, that's close. That gives you 32.
4 times 7?
Yep. Go for it. Split it.
Oh, yeah.
Beautiful. 4 times 7. Perfect. And then now, do you remember what to do? You split them apart.
Oh, yeah. And
good job. What if I gave you this one right here? 3/4 divided by 2/3. Let's throw a fraction at it. If you have 3/4 and you're dividing it by this fraction, do you remember what to do with that second fraction? Good. Multiplying by the reciprocal, girl. Good job. Straight across. Good job. Good job. If I gave you this one right here, 10.5 divided by 2, would you know how to set up that long division and do that division?
wait, what?
I'm dividing 10.5 by 2.
I don't like times it.
Well, this is, have you guys been doing your long division?
No.
You haven't been doing your long division? So if you're doing this, the 10.5, remember? You did this a little bit. Remember how the top number
Oh, yeah.
is getting rained on? So you got to make sure you put that top number so it has a little roof over its head, right?
Oh, right. I remember it.
And then you put that 2 right here. All right, now what do you do? Does 2 go into 1?
No.
Nope. Can you go 2 into 10?
Yeah.
Yep. So what times 2 gives you 10?
Wait, 2. 4. Okay, 5.
Yep.
Yeah,
So
5.
where do you put that 5? Perfect. And then you times those 2.
Is 10.
Yep.
So
Put that right there. Subtract.
And then you bring the 5 down.
Round the 5 down. And then before you go any further, see that decimal? Bring that decimal straight up right there. Perfect. Now keep going. 2 into 5. What times 2 gives me something close to 5?
2 times 4. Wait.
See, it's really forcing you to know your times tables. You're like, man, I'm trying to get 5. What times 2?
2.
Yep, because if you go 2 times 3, it gives you a 6 too far, right?
Mm-hmm.
So you're right, 2. 2 is as big as you can go. So put that 2 right there. Times it.
Oh.
So times this 2 and that 2. And then you're going to put that 4. That 4 is going to go underneath this 5 right here. And then you subtract. And then to keep going, if you go to this next spot, that lets you bring down a 0 all the way. There you go. And then 10, 2 into 10.
2. Oh, 5.
Yep.
Right there.
There you go. And then you multiply, get 10. No remainder. Is this a terminating decimal or a non-terminating decimal?
Terminating.
So it keeps going forever?
No, terminating.
Terminating, yeah. Terminating means stops, right?
Yeah.
Non-terminating would be like if this was going on forever, forever, forever. All right. I'll leave the board up to you. What math problem do you think is just really getting? Is it the fractions? Is it the decimals? Is it these radicals that we were doing? Or is it something that we did way in the beginning? I could throw out a million other radical problems for you. Like when you look through your notes, because you haven't taken a big test yet, right?
Mm-hmm.
So it looks like most of your problems are going to be these square roots. They're going to be these fractions. Yeah, take a look.
The
opposite
ones are
The
like
opposite.
not like kind of like doing like this
The pluses and the minuses. So do you like to do it on number lines?
No.
You don't? All right, so let's talk negative rules real fast again. You and me. All right, to get you really, really good with your positive and negatives and not have to really worry about number lines. Do you remember how I taught you how with negative, positive numbers, they're either both the same and you make them into an even bigger negative number, or the only time in math you ever really subtract is when you have a negative value and a positive value. Do you remember those kind of? So if you have numbers, obviously no sign change here, right? Nothing like this. That's a double sign, right? So there's no double signs. What do you do when you have -4 and -3? How many negatives are you going to get out of that? What if you had 4 plus 3? What's 4 plus 3?
4 plus 3 is 8. Wait, 4, 5, 6. Yeah, 8.
You sure?
Wait, 4, 5, 6, 7, 7.
7, right? So you got +4, +3 gave you a whole bunch of those 7s, right?
Mm-hmm.
What do you think when you have -4 combined with 3 more negatives? How many negatives are you going to get?
2. Positive what? Oh, wait, what?
I'm just trying again. When I've been teaching this for 30 years, people all their life they've been taught minus means minus.
Mm-hmm.
But do you see how this problem, see how I did in minus?
Mm-hmm.
See how that blows people away?
Mm-hmm.
This, when you have 2 negative values, when you see they're both clearly negative, they combine into an even bigger negative number. Some people, they look at this and they're like, oh, this is a double sign, this is plus, but that's not a double sign. A double sign would be like if you add -5, that would be like a double sign, right? Mm-hmm. But when you have something like this is just two negative numbers combined into an even bigger negative number. And people, they think minus means minus. They'll try to get 1. They'll try to make it positive. Over here, this is the time you really ever subtract in math.
Oh, okay.
So if you took like 6 away from 2 in your brain and got 4, now you look at the number that's bigger and the sign on that bigger number. Yep, excess negative.
Yeah.
And you only find the difference when you have a negative number and a pot. That's the only time in math you ever really subtract. So if I had this 3 right here, positive, and -10, what do you think? It tells you the minus.
Yep. Yeah.
So what's that going to give you?
7.
7, and then the sign. Is it positive 7, girl, or -7? Yep, because you have more negatives here. Does that kind of make sense a little bit? Come on in. How about this last one here? What if I gave you, I need to remember, one of those with negatives in there? All right, so this one has you change your double signs first.
4.
Yep.
Well, wait. Yeah.
So that becomes
positive
4,
-7.
-7. Now, what do you do when you have a positive and a negative value? Do you remember what you always do? Good. You found the difference. Now, perfect. One more here. Because you're on a roll, girl. What if I gave you plus -3 -7? Try that one. Good. Okay, now careful. You got 2 negative numbers. They're going to combine to an even bigger negative number.
4. Is it just -4?
Nope. How many? If you had 3 plus 7, what would that give you?
4. Oh wait, what? Oh, it's 10. Sorry.
10. So here, don't. Because these are both negative, you're combining them to an even bigger negative number.
Okay.
So it wouldn't be 4. It's going to be -10. -10. Good job.
Okay.
And again, like I said, the people I teach all this, they think minus means minus, but when you're looking at positive, negative problems, the only time you ever subtract is when one number is clearly positive and the other number is clearly negative. That's the only time you ever really subtract in algebra. Okay. Good job, Camille.
Thank you.
You're welcome. It's always a pleasure working with that lady.